Hello students, today we are going to study stack under data structure. A stack is one of the most important and useful non-primitive linear data structure in computer science. It is an ordered collection of items into which new data items may be added, that is inserted, and from which items may be deleted or removed at any one end, which is called the top of the stack. Whenever we are talking about stacks, we think about a stack of books as shown in this picture. If you want to add a book, we always add a new book on the top of the stack. And if we want to remove a new book, we remove the topmost book. So it is last in, first out data structure. As all the addition and deletion in a stack is done from the top of the stack, the last added item will be the first removed from the stack, and that is why stack is also called last in first out or LIFO. Here you can see an example of a stack. Let us see the pictures one by one and follow them. See the first picture here. This is a stack which is empty. That is, it does not have any element. If you see carefully, my students, you will see that the stack is looking like an array which is placed vertically. When the stack is empty, the value of the top here is equal to -1. This top is equal to -1. So if the top is -1, we should understand that the stack is empty. In the second diagram, we have inserted or pushed one element into the stack. While talking about a stack, whenever we are inserting an element into the stack, it is called pushing. So the value of the top will also increase by 1. So what is the value of the top now? It is equal to 0. So students, if you notice carefully, the value of the top is matching with the index of the element which we just inserted. Next, let us insert another element 33. That is, we are pushing 33 into the stack. So the value of top now will be equal to 1. So again, if you notice, the value of top is equal to the value of the index of the last inserted element, that is 33. If we insert one more element 47, what will be the value of the top now? It is equal to 2. Now we start to delete the elements from the stack. Deletion of an element from the stack is called popping or pop operation. Whenever we are popping, remember always the last inserted element will be popped out first. What will be popped out first then? 47. As soon as we pop out 47, what is the value of the top now? It again is equal to 1. So whenever we are inserting an element, we increase the value of top by 1. And whenever we are deleting or popping out any element from the stack, we decrease the value of top by 1. Now if we again insert 77, what will be the value of top now? It is 2. Again, if we delete an element or pop out an element from the stack, always which element will be popped out? The last inserted element, that is 77. I hope push and pop are clear to you now. Now we come to the formal definition of push and pop. So push is the process of adding or inserting a new element to the top of the stack. Pushing an element to a stack will add new element at the top. After every push operation, the top is incremented by 1. If the array is full and no new elements can be accommodated, then the stack overflow condition occurs. So my dear students, if I continuously insert elements here, suppose I insert 50, 51, 52, 57, slowly the stack will get filled up, and when the last element gets inserted, after that we cannot insert more elements into the stack, and this condition is called stack overflow. Kindly note that when we insert an element here at the last position of the array or the stack, what is the value of top here? Top will be equal to 0, 1, 2, 3, 4, 5, 6. So the value of top is 6 here. And if you note, what is the size of this array? The size of this array is 7. So if the value of the top is equal to size minus 1, we can say that the stack is full or stack overflow condition has occurred. Now we are coming to pop. The process of deleting or removing an element from the top of the stack is called pop operation. After every pop operation, the stack is decremented by 1. Here it means that the top is decremented by 1. If there is no element in the stack and the pop operation is performed, then the stack underflow occurs. So if you note carefully, if the value of top is minus 1, it means that the stack does not have any elements now. That means we cannot pop. So we say that this condition is called stack underflow. Now coming to the algorithms, which are both very important, that is algorithms of push and pop. I'll just show you once. Kindly note, during pushing, what are we checking? Whether the stack is overflowing or not. As I just now explained to you, if top equal to size minus 1, we say that the stack is in overflow condition and we exit the program. Otherwise, we increase the value of top by 1 and then we insert an element, that is data, into that stack. Kindly note here that the stack here is represented as an array. Stack is the name of the array and top here is actually the index value of that array. In a similar way, if we see the pop operation of a stack, we see that if top is less than 0, when is top less than 0? So just now I have said to you that if the value of top is minus 1, then the stack is empty. So instead of writing less than 0 here, you can also write top equal to minus 1. That works as well. What did we write here then? If top is less than 0, we say that the stack is an empty one. And we cannot perform a pop operation since no element is there. How can we pop out an element from that stack, right? Otherwise, what should we do? If I say pop, my dear students, I don't have to really specify that from which index should I pop out the element. So in case of a stack, popping means always pop out from the top. So else remove the topmost element. Which element is there on the top? Obviously stack top. Just now I have shown to you, right, that whenever we are inserting any element into the stack, we notice that the index of that particular element, see, the index of that particular element is equal to the value of top. So we use that and we wrote this particular line, stack top. Stack is the name of that stack, that is the name of that array, and top is the value of the index. So what is data now, students? Data is actually the element which we just now removed from the stack. And what is the value of top? After removing the element, we can decrease the value of top by 1. Kindly note that this top equal to top minus 1 should be done after we have popped out the element, not before that. I hope the topic is clear to you. Thank you, students.